Welcome to this evening's session. It is having a look at probability distributions, okay, essentially binomial and normal this evening. Just a little bit about myself. My name's Simon. How are you doing? I am Casio's principal technology trainer. Okay, I've been working with them for about 10 years now. I mainly do the training online or in person or develop resources for them. But before that, though, I was a teacher. Okay, I was a head of department teaching A-level maths and further maths using this handset in almost every single lesson, just to see, give the chance for the students to see how useful the handset is and how beneficial it can be in teaching. Because I use the handset in every single lesson, I always start off with resetting the handset, and we'll do that in a second. But just to give you an idea of what's going on, Casio Education, we're here to help teachers and students. So we do training sessions, departmental and solo. We support students with learning how to use the handset and also with revision webinars. We provide loan sets, and as you can see, we do deep dives, and soon there will be an online CPD course that you can have a go at. So essentially, we are here to make life easier for yourself, and hopefully you will get something out of this evening's session, even if you have used a handset before to do a little bit of probability. So, like I said, it is just distributions tonight. The previous deep dive, we had to look at stats. This is now distributions. Like I said, basically binomial normal, so we're looking at A level this evening. Um, so, why use a graphic calculator? Well, I used to use it all the time. It is not just for exams, it is an excellent teaching tool. Obviously, students can have a go at something, see whether it works or not. They can change the way that they approach things. And they can come up with an idea and see whether it works. So prompting a little bit of curiosity, oops, and also seeing whether they've made the right decision or not. Okay, so really useful for students just develop their own confidence when approaching a topic. Some areas that they might find tricky with distributions is understanding the calculations, what's actually happening, what they are looking for, interpreting the distribution. Is it discrete? Is it continuous? Are they looking left, right, exact, things like that? How do they actually use a calculator properly when approaching distribution probability questions and hypothesis testing? And also visualizing problems, drawing graphs. What should they look like? So hopefully, like I said, we'll be able to help you on some of these issues. I've got an emulator on the right-hand screen. I will be going through most of the calculations live. If you want to follow along, please feel free. However, this is not a skill session, so I won't be detailing the keys that you need to press. But just to make sure that I'm going to get the same response as the shown screen captures, I'm going to reset the handset to begin with. So that's accessing the system manager, resetting the main memory. And there you go. I've now reset the handset. And if I press menu again, this gives me the nice introduction to working out some probabilities. So we're going to look at it in context of a couple of exam questions. Here is one from Edexcel. Okay, it is a binomial question. It's asking two things in the first part. It wants an exact probability and then a more than probability. Okay. And then later on, we're going to look at the second part, which is a hypothesis test. So first part, it wants exactly two games. So we've got a distribution where we're doing something 15 times and probability of success is a third. Okay, I'm going to show you different ways of approaching the topic in the classroom. This is not necessarily what you would do in an exam. Okay, it's up to you to show students how to effectively use the handset so that they have the option Okay, so if we want exactly 2, that is the calculation that students could attempt to do manually. You might approach the beginning of binomial probability this way. So we can use the NCR functionality. So I need to go to run matrix, okay, and there I can enter my N. I will use option. Oh no, sorry, not that, probability. There you go. Probability to get my NCR and then choose. So 15 choose 2. And I calculate, I get the 105. Now you could attempt to do this calculation all on a single line. But just for demonstration purposes, I'm going to show you how to do it in stages. So I'm going to recall the answer and then multiply. So I can use answer, so that's the last calculated value, and then I'm going to multiply it by a third. So I can use the fraction template, and I need to square that. Oops, hang on, get it right, squared. Okay, I can calculate. So I get my improper fraction. Notice, however, that when you are raising fractions to an exponential power, you don't actually need to use the parentheses. So just if you check out the screen capture there, I can demonstrate just by redoing that calculation. I can delete the parentheses and I get the same value. So that's, say, an exam tip, a little bit faster, that's all. And then the last thing would be I need to multiply that answer by the probability of failure raised to the power of 13. So there you go, 2/3 raised to the power of 13. Okay, and we get the probability almost 0.06. Okay, so that is how you would perform a manual calculation using the formula. How about using the shortcuts that are available on the calculator? If you've used scientific calculators, you know that these are available. So this is called BPD, binomial probability. So what we need to do is we can go option, start distribution and choose binomial. There are 3 options here. We've got exact probabilities, cumulative and inverse binomial calculations, and we'll look at all of those in this session. So if I choose BPD, I want my value of x to be 2, and then it is n and p, so n15 and p is a third. I could enter that as calculation, 1 divided by 3 if I wanted to. And I calculate, and there you go, I get the exact same value. Okay, so that's using the shortcut. However, you may want to approach this whilst you are teaching, so that you can provide students with a list of probabilities, so they can, if there's more than one calculation to be done, they can refer to that. So what we're going to do is go stats mode this time. Okay, and in list 1, I'm going to manually enter the values of x that I want. So I'm going to start with 0, and I'm going to go all the way up to 5. Okay. So there you go. I've got 0, 1, 2, 3, 4, 5. And I've chosen 5 for a particular reason. You'll see that later on. Then I need to do BPD on a list. Okay. That allows me to choose distribution and binomial, BPD, so you can also access these shortcuts within stats mode. I can do it on a variable or a list. I want to do it on list 1, which is where my values of x are, so I need to enter the parameters. So n is 15, and I'll do a calculation this time, 1 divided by 3. There you go. You don't have to, but you can save the probabilities to a list. So I'm actually going to save these to list 2. Okay. And then when I calculate, I get a list of values. Okay. But I can then exit and they have been stored as list 2. And if I scroll down, you can see the probability that x is exactly equal to 2 is given. Okay, so that's another way of approaching the problem. However, what if you've got a value of n that's slightly larger? You know, I only entered 0 to 5. Here, n is actually 15. It could be even larger than that. That might be a little bit monotonous or even prone to error when entering these. So what we can do is let's just delete the lists that I've got. Okay. And you can actually enter a sequence in your list if you want. So what I'm going to do is use the list command to get to sequence, and I start off with my function, which is just x. My variable is x. There you go. What's my first value? What's my last value? And what is the step? So going up in integers. Okay. And then when you confirm, what happens is you get a list going from 0 to 5. Okay, so that could have been a list from 0 to 100. A lot easier to enter using the sequence command. Then I can do exactly the same as before. I can do, let's get it right. There you go. I can do a binomial BPD on list 1, saving it to list 2. And then when I exit, I get my values. And again, highlighting the value. I should point out it is very much worth highlighting the values because what you can see in the list is truncated. Okay, so if you're working to 3 sig figs, in this case, you would actually have to check to see whether that needs suitable rounding. Let's see if 3, there you go. If, for example, you know, x was 3, you can see that potentially if you're going to 4 sig figs, perhaps, you would have had to modify that value. Okay, so please bear that in mind that all lists on the handset, they are truncated. I should say, if you do have any questions, please enter them in Q&A in the background, and I will try to answer them at the end of the session if we've got some available time. Okay. So next thing we can do is calculate a cumulative probability with exact values. So it's the same distribution. This time, this is the second part of the question, which is more than 5. Okay, we know that we can do a 1 subtract 5 or less. Or actually, what we're actually trying to calculate is x is 6 or more. Okay, so we can sum a list. So list 2 is actually all the values of x from 0 to 5. So it would be quite nice if we summed that. That's why I chose to go to x is 5. So if I just go to list 3, I can then use the list option. So I can sum some values, and I am going to sum list 2. Okay, and that will give me a value in list 3, which is actually the sum of all the individual probabilities, x equals 0, x equals 1, x equals 2, and so on. And you can see it's 0.61. Okay, what we may want to do with that is then subtract it from 1. I can highlight the value so I get a full decimal, and then I can try and do that manually. However, it might be useful if I just do the calculation within the list editor. So what I can do is then I can say, okay, in list 4, I'm now going to do an operation on the whole list. I don't need to, but I'm just demonstrating what you could do. So I could do 1 subtract all of list 3. Okay. So if list 3 had more than 1 value, I would get more than 1 value in list 4 as well. So when I calculate that, I get the probability. So this is 6 or more. Okay. So that's one way of approaching this. A very nice way that you can manipulate lists, comes in quite handy. Alternatively, You may want to extract that value. Maybe you want to do something with it, do some operations on it. So what I can do is go to Run Matrix. Let's just clear the screen there. If I do one subtract list 3, or I could just recall list 4, but just to demonstrate that I could just recall. Okay, so this is actually a list. The answer is a list. It's not a particular value, even though there's one value in the list. But if I wanted to do something to that value, I can recall it. So that's my list answer. And I want position number 1. Okay. And when I do that, that is now my answer, and I can do a calculation on it if I wanted to. Okay. So that is how you can recall the value from a list. Quite useful if you have calculated some probabilities and you want to do some calculations on them. Okay. So we've calculated cumulative probability from adding up all the exact probabilities, doing that in list mode. What if you want to use the available shortcuts? Obviously, this is going to be a lot faster, but I am trying to demonstrate, different approaches. So here we have the same probability. We're looking for 0.38, so this is 6 or more. So I want to do a BCD calculation. Let's just get rid of all those. So now I can do a BCD binomial. Okay. I can do a left hand. I don't have to include the 0 because that's a lower bound. If it is 0, I could just enter 5 as my upper bound, but let's demonstrate that I'm doing it between bounds. My n is 15 and my probability of success is a third. Okay. When I calculate that, I get the 0.61 that we've seen earlier. So don't have to add up the individual probabilities. I get my cumulative one straight away, but that's 5 or less. I actually want 6 or more. So what I can do is then do a 1 subtract that answer. So this is now probability of x is 6 or more. Excuse me. Or, as you may have figured out, if I can do a cumulative probability calculation between bounds, instead of between 0 and 5, why don't I do it between 6 and 15? So this is now a right-hand side probability calculation. So let's do a BCD between 6 and 15 instead. My n is 15, and I'll do 1 divided by 3, just to show I can use a calculation. Okay, so there you go. That's the shortcut. You can do left-hand side, you can do right-hand side probabilities, you can even do central probabilities between bounds. Okay, so quite handy there. You don't actually have to do a 1 subtract a left-hand side probability, as you may have been doing using the scientific, perhaps. You can see that the calculation is a lot easier to perform. How about calculating the probability by using a list? So going to the right-hand side. Okay, so just to demonstrate, I'm not suggesting that you may want to do this in an exam, but this is a method that you could use. Let's just clear the screen first. And then if I go to stats mode, oh, jump the gun a little bit. Okay, what we need to do is I need to create a list of lower bounds, so a bunch of zeros effectively. So there are 16 items I want to create, and I am going to create it for the dimension of list 1. Okay, so that means list 1 has now got 16 zeros. Okay, if I go to stats mode, I've now got the 16 zeros. Let's just delete everything else. Okay. So 16 zeros, a really fast way of just entering the same value in each row. Okay. I want a list of upper bounds now. So what I'm going to do is create a sequence. Okay, so a sequence of values from 0 to 15. So as you saw earlier, instead of going from 0 to 5, I'm going to go to, oops, sorry, I'm going to go from 0 to 15 in integer steps this time. So I'm going to get all of my probabilities this time, not just 0 to 5. Okay. When you enter those, so I've got a lower bound, I've got an upper bound, so I can do a calculation. I can do, I can do a BCD on a list. So here I can choose my lower bound list and my upper bound list. Notice that N and P have been carried forward from my previous calculations. That's perfectly okay. But I don't want to save my results in list 2. I'm going to save them in list 3 instead. Okay. And this time when I calculate, I get a list of values. This is the list screen. If I want to go back to the list editor, there you go. You can see I've now got a list of cumulative probabilities. Okay, so between 0 and 1, 0 and 2, 0 and 3, and so on. If I have a look, I can scroll down to 5. And you can see that I have got the cumulative probability, so 5 or less. Okay, so here I have the 0.61. I then need to do a 1, subtract that to get 6 or more. Okay, how do I do that? Well, let's have a look. I could extract the correct value. So let's go to run matrix again. Let's get rid of everything. And then I want to extract just a particular value from a list. Not the whole list, just a particular value. So this time it's 1 subtract, was it list 3, and I want the 6th row. Okay, so that's where X is 5. Remember, it starts with 0. So I can extract that value, and now this is the probability X is 6 or more. Okay, so that's quite nice, showing that you can extract values from a list if you use the list technique. Okay. Personally, I would probably approach this using table. In the good old days, we used to have tables of probabilities. Not so important anymore, but it's quite nice that you can make your own tables with any N and P values. So let's go to table. Okay, so this is table mode. Normally the same functions in graph will be carried forward to table. There's nothing there. You don't just have to enter, a polynomial, for example. You can actually enter calculations. So we're going to enter a BCD calculation. So I'm going to access that with stat and dis. There you go, binomial and BCD. Okay. I'm going to start off by having a normal cumulative on the left-hand side between 0 and the variable x. So those are my 2 bounds. My n is 15, and a third is my probability of success. Okay, so this is going to be left-hand side. Then I need to tell the calculator what the table needs to populate. So I need to say what are the values of x. So the table settings need to go from 0 to 15 in integer steps, remember? So that will give me the cumulative probabilities for the whole distribution. So when I can exit and populate, those are my cumulative probabilities. And then I can scroll down to get the value that I want to subtract from 1. Okay. You can extract values from a table. It's a little bit complicated. because the table is actually presented as a matrix. So I won't show you how to do that. However, because we do need to subtract this value from 1, instead of having a left-hand side cumulative probability table, why don't we approach it from the point of view of creating a right-hand side probability instead? So let's do BCD between bounds. So let's exit back to the table editor. Let's do another BCD, but this time let's have the lower bound as my variable x. My upper bound needs to be the value of n, which is 15. Then don't forget to enter n as well. And my probability, I'll enter it as a calculation here. Okay. And then when I calculate, I don't need to change the variables in the settings because it's still going to be 0 to 15. I choose table again, so I've now got the blue values are left-hand side, the red values are right-hand side. If I scroll across, what you can see there is this is for 6, or so x is 6 or more, we get that 0.38. Okay. Notice there is a diagonal correlation going on there. If you add the 5 blue value and the 6 red value, you should be getting 1. Okay, so that's quite nice to demonstrate to students when they are trying to understand what's going on with left-hand side, right-hand side, one subtracts the other, for example. But quite nice that you can use BCD between bounds. In this case, x going all the way up to 15, so a right-hand side probability. However, I've been saving the best till last, shall we say. We have an app on the handset called Distribution. Now, this is fairly recent. I think it's about 2 years old, maybe a bit older than that. And it deals with all sorts of distributions that you maybe want to use, especially binomial normal for A level, but there's also, Poisson, chi-squared, geometric for further. Okay, you do need a relatively updated handset though. You need OS 3.6. If I just show you very quickly, you get to that through System Manager and you check the version. The latest is 3.8. You need 3.6 or later, otherwise you won't have distribution on your handset. To get it, quite simple. Just go to the education.casio.co.uk website. And the easiest thing you can do is just search for OS update in the search box on the top left. Okay, that'll actually take you to the page where you can download the updating software. You just need to connect your handsets to the computer using the cable that came with it. It's a mini USB cable. Okay, takes about 3 to 5 minutes to update. Okay, and then you will have distribution. If you haven't got that on your handset at the moment, don't worry. I'll just demonstrate what it can do, and maybe you can have a look later on. Also, I should point out that you will be getting a link to a video of this session as well, so you can watch it later on. Okay. So what does distribution do for you in this context? Well, let's go to distribution. We are going to deal with the binomial problem. So if we choose binomial, we want the probability that x is exactly 2. We know what that value is. So we've got the parameter entry screen, and at the bottom you can see there are 4 different regions: left-hand side, central, right-hand side, and exact. Okay, we want exact, so we can choose that, and you can see that the region has now changed. We want to enter the correct parameters. Now, nothing has already been entered in distribution, so I need to start from scratch. So x is 2, n is 15, and the probability of success is 1 over 3. Notice I can enter that as a calculation. Okay. Then you can execute and you will see that you get not only the probability presented to you, but the parameters n and p and a vertical line graph with the value of x equals 2 being highlighted. So this helps students to understand what is going on if they're talking about mean, median, mode, for example, skewness of a distribution, what they're actually looking to calculate, whether it's a sensible value. But again, what we have here is the probability is presented as a truncated value. So it is worth scrolling across to the probability and using option just to see what the full value is in case you wanted to make any rounding decisions. Okay. Next thing we can have a look at is if we've got the probability of x is equal to 2, how about getting a cumulative probability? So we want greater than 5. So this is 6 or more, remember. We approached it previously, potentially doing 1 subtract 5 or less. So we can change the region quite easily because now I've got all the regions available at the bottom of the screen. I don't need to change any other parameters. So this is a nice fast way of doing this. So let's change the region to go to the right, and you can see that the x value has stayed the same, but the region has changed. Okay, so I now get a new calculated probability with the relevant vertical lines being shaded. Okay, now that doesn't really help because I wanted 6 or more, so it is quite easy to change the value of x. All I have to do is just enter a value. Don't need to do anything else so long as the x value is highlighted. And then when I calculate, the vertical line graph changes to just show 6 or more being highlighted, and a new probability is given, the 0.3816, which is we are familiar with. Again, this is truncated, so let's have a little look at it. There it is, just in case we wanted to do some rounding decisions. Okay. And I should mention that you can actually extract these probabilities, and I'll demonstrate that later on. Okay. So we've had a look at doing the first part of this question. So finding out probabilities. Second part is a hypothesis test where n is now 32. P is still a third. Okay. And we are looking at the right-hand side because of the wording of the question, helping win more than a third of the games. Okay. So what we need to do is we could approach it from the point of view that we've got a new distribution. Here are our hypotheses. H0, we think it's a third, but then H1, it could be more than a third. We want 16 or more, so that's the information given in the question. We could do an inverse calculation just to give us a ballpark understanding of what is going on. Oops, let's do that. There you go. So I could do an inverse binomial calculation in run matrix. So this was a 5% test. So if we think about it, that means that 95% will be on the left. My value of n is 32, and my probability of success is a third. Okay. When I calculate that, it is telling me that the value of x is 15. Okay. I should say that you need to approach this value with caution. Okay. It may be 15. It may not be 15. Okay, so this is just a ballpark figure where you can have a look at calculating the values, see whether they are correct or not. We can check the probability quite easily by doing a right-hand side cumulative calculation using BCD. Okay, so what's the probability between 15 and 32 in this case? Let's use n is 32 and There you go. Just putting a third in there just to make it look neat. So as you can see there, that is 7.7%, which is bigger than 5%. So it's not in our critical region. Okay. So then you can say, okay, because we're looking to the right-hand side, why not have a look at the next value of x, which is 16. Let's go all the way to 32, and there you go. Let's use calculation. You can see that in this case, that 16 or more, okay, is in fact 3.7%. Okay. So we have established that 15 is not my critical value, not in the critical region. 16 is my critical value. Okay, the first value of x in the critical region. So 16 or more is your critical region. Yeah. You could, of course, approach this using a table. Okay. So we want a table of probabilities. Let's go to table. Let's delete all of these. Okay, just so we have one table. Let's enter a BCD calculation. But this time having it on the right-hand side, so my lower bound is my variable x, okay? And let's go all the way up to the value of n, which is 32. You don't have to. That would just give me 33 values. But if you're approaching this from scratch, you may not know which value of x you're looking for. Let's do a calculation. I do need to set the table again because remember it only went from 0 to, 5 to begin with. Now we need it to go 0 to 32. Okay. Then when we calculate the values, we get our table. Okay. And then we can scroll down and we can see that when x is 15, probability 7.7%, 16, 3.7. Okay, so 16 or more critical region, x equals 16 critical value. Okay, so quite nice that you can create your own probability tables. If I wanted to use distribution mode when approaching this question, quite nicely, what you can do is just change the parameters. So let's go back to distribution, choose binomial again. We do want right-hand side. Doesn't really matter what the value of x is, but we do need to change the value of n. Okay. And then when we calculate, there's our value of x, and it's giving us a probability. We don't want x to be 6. We think it could be somewhere around 15, but that would be trial and error. So what you can do instead is you can change the probability. If we change the probability to 5%, what happens is that you'll get the 7.7, and you are told that x is 15 or more. Now, you may think that why isn't it giving me the right value? Well, what it's done here is just as with the inverse binomial calculation earlier, it is giving you the value of x that has at least 5%. Okay. So x is 15. So this is one of the values that you need to get the marks. Change the value of x, so we need to change it to the next largest one. So you highlight the x's and enter 16. You recalculate. You get the 3.7%, and you can interrogate that as well if you want an exact value. Okay, so really useful when doing a hypothesis test. Using distribution, very easy to find the critical values and critical region. Okay, but like I said, as a teaching and learning tool, using lists, using table, quite handy. Moving on quickly to normal distribution. Okay, just to demonstrate some of the features. What we have here is another exam question. Okay, this one was actually done quite poorly in the exam. There was a little bit of understanding required to approach it. So what we have here, first part, more than 15 minutes. So what we have is a distribution and a probability to calculate. So quite easy to go to normal. What we want to do is choose the correct region. So this is a right-hand side probability. No parameters saved. Notice we've got the standard normal. So sigma is 1, mu is 0. X needs to be 15. Enter sigma first, which is 4, and then mu. And then when you calculate, you get your graph as you would expect. The shaded region shows you the relative probabilities. And we're given a probability of just over 10%. Again, you can interrogate that if you want to make some rounding decisions. Okay. Next part of this question is hypothesis test. What we have here is it's a sample of 20, so we've got a sample distribution. We've got a hypothesis, so it's 10, but we think it could be more than 10. And we're looking for more than 11.5. Okay, so what we need to do is we have got to change the parameters. So I need to exit back to that screen. X is 11.5. Sigma, okay, that needs to be divided, okay, by root 20. Because it is a sample, so you can do a calculation here if you want. And then we can scroll down, and when we execute, okay, what we've got there is probability X larger than 11.5, just a little bit less than 5%, so that's significant. Okay, you can scroll across and interrogate if you like. So when you want to make a rounding decision or not. Of course, there is another way to approach this. You could have said, all right, what's the value of X where the probability is 5% on the right-hand side? So what you can do is just change what the probability is by entering a value. When you do that, because this is continuous, you'll get a nice value of X, which again, you can interrogate. Okay, so 11.47, a little bit smaller than 11.5. So that's your critical value. You know that 11.5 is in the critical region. Okay, so quite nice there. Same question, keeps going. Slightly different distribution this time. Okay, and we said less than 2. Okay, so again, what I need to do is change the region and the parameters. So I've got to go left-hand side this time. X is 2, sigma 3.5, and the mean is 5. When I execute this time, I'm getting shading on the left-hand side with the probability, was it 19.5%, which I can interrogate. Second part of this question, this is where things started going wrong for students, according to the examiner's report. We've got a conditional probability this time, so probability that t is less than 2 given that t is greater than 0. It requires this calculation. Now, doing this in one go, not ideal. However, using the calculator, I can break this up a little bit. Okay. I've got the same parameters, so what I can do is just choose the region that's different. So here I have default 0 and 0. I want to go between 0 and 2. Okay. When I calculate, I get a probability. So this is actually the numerator of my fraction. So it is 0.1191. Okay. What I can do is extract that particular value. So I go to run matrix. Let's just delete everything. I can recall the value of P. So that's my last calculated probability, and I can store it as the variable A. So I can recall that later on when I wanted to do this calculation fraction. Okay. Then I can go back to distribution. Notice the sigma and mu are still there. I want t greater than 0, so that's right-hand side. Let's choose x is 0, and then when I calculate, I get my probability here. This value of p, 0.9234, I can then extract that. So I've got a fraction this time. So I've got the value of between 0 and 2 stored as the variable a. I now want to divide that between my last calculated probability. Okay. And then when I calculate, I get, was it 12.8-ish%. Okay. So that's how you can extract your probabilities, which is quite nice. Last part of this question. Okay. Slightly different. You now can't complete something in less than 2 minutes, so only including values greater than 2. The question is now looking for a median time. Okay, so median, you're instantly thinking about the value of a half somewhere. To calculate the median, what we need to do is find out the value of t, where the probability of, if it's greater than that value divided by the probability of greater than 2, then it's a half. If you think about what's required graphically, that does make sense. Okay, so what we can do, if we go back to distribution, okay, what we want to do is calculate a right-hand probability where it's greater than 2. If we do that, there we have approximately 0.8. Okay, so that's the denominator of my fraction. That allows us then to work out what a half of that is. So let's go back there. So I'm going to put it in parentheses. So what is a half of my recalled probability? So the 0.8. And I'm going to store that as a variable b. See? So approximately 0.4. Okay, so 0.4 is equal to the probability that t is greater than t. I can then go back to distribution, normal, and I want right-hand side again, so I don't need to change the region. Doesn't really matter what the value of x is, or t in this case, but if I execute again, what I can do is say, well, I need the probability to be that 0.4 to find the value of x. So now I can just enter my variable b. Okay. And then when I calculate, I get a nice value of x, 5.8, which I can interrogate. So quite nicely, you can extract values, manipulate them, and then put them back into distribution. Final question, slightly different. This is asking about percentiles. Okay, so it's something that you may come across. So what we want to do is find a value of A and B. Um, it's between the 10th and 90th, which conveniently is symmetrical about the mean. Okay, and we want that probability to equal 0.8. So what we do is we have to change the parameters. So I've got to go back to the parameter entry screen. We want a central region. Doesn't really matter what your lower and upper bounds are. We just want to calculate a probability. So I'm going to go to the left of the mean and to the right of the mean. My sigma is 5.19 and my mu 22.6. Okay. When you calculate, you will get a probability, but it's not using the values of x that you want. Okay, you've got the shading either side of the mean, doesn't have to be either side. So what we now do is we change the probability to the one that we want. So let's just enter 0.8. And this will then change the values of x. Okay, so we've got a lower bound 15.9, upper bound 29.2. However, it is asking for the range, not the values of x. So what you can do quite nicely is you can actually extract those values of x. And you can interrogate them if you want. Okay. But if we go to run matrix, let's just delete all of those, you can recall those x values. So you can do that from distribution. So here we have x1 and x2 inverse normal. Okay, x2 will be the larger value. To get the range, we need to subtract the smaller value. And you get the range 13.3. Okay, so quite nicely, when doing normal, for example, it's quite easy to extract the x values and use those. Okay, so hopefully that has been useful.